So our 4 steps for solving by factoring are on the right-hand side here. We always want to make sure that our equation is set equal to 0. So if there's some terms on one side of the equation, we want to move them over to the other side. Right. In this example, 2x squared plus 2x minus 12, that's already set equal to 0. So our first step is taken care of for us. Our second step is to determine the factoring method that we want to use for my 2x squared plus 2x minus 12. When looking at factoring, we always want to look for the GCF first. Right, so looking at all of these terms, right, we can see that we have a GCF of 2. All of these coefficients are divisible by 2, and that's also the biggest number that each of these terms is divisible by. Right, so my first method of factoring is going to be GCF. So I'm going to go ahead and factor out that GCF now. And anytime we factor out a GCF, we write that number in front. And then we write the reduced expression in those parentheses. I also want to make sure that my trinomial that's on the inside of my parentheses now is factored completely. All right, so I can use my X method on this expression on the inside because I know that it's a trinomial and my leading coefficient is 1. In other words, I have an x squared with that imaginary 1 in front. All right, so I can also factor this even more by using my X method. So I'm going to set up my X here. I want two numbers that multiply to -6, but also add to +1. And so those two numbers that satisfy this would be a +3 and a -2. Because 3 times -2 is -6. And then 3 plus -2 is a +1. So I'm going to keep my GCF in front again, and I'll create my factors using that +3 and -2, still setting it equal to 0. Once I've factored, I want to set each of my factors equal to 0 and solve for x. So 2 is considered a factor, so I'm going to set it equal to 0. I'll take my x plus 3, set it equal to 0. My x minus 2, set it equal to 0. Right? Now looking at this 2 equals 0, right, I'm only concerned about solving for x here. And so this first equation doesn't contain an x, so I wouldn't have to consider it for one of my solutions. Right? We also know that 2 equals 0 is not a true statement, so we can just throw out that equation. So I've got x plus 3 is equal to 0. I'm going to subtract 3 from both sides to get x is equal to -3 as one of my solutions. And then I'm going to add 2 to both sides to get x is equal to a +2 for my other solution. And looking at what these solutions mean, or if you ever want to check your work as you're going through, all right, you can plug the equation that you're given in the problem into Desmos, and you can check where those zeros are. All right, so I went ahead and graphed this in Desmos using that 2x squared plus 2x minus 12, right? And you can see where the graph crosses the x-axis here is in fact at -3 and +2. So I know that I solved this quadratic function by factoring correctly.